So I'd like to introduce our next speaker. That's Dr. Ranjith Udawatta, a research science professor here at the University of Missouri and a collaborator and one of our core faculty at the Center for Agroforestry. So please welcome Dr. Ranjith Udawatta, who will be talking about soil ecosystem services. Thank you.
Good morning, everybody. Thank you very much, Gregory, for the introduction. I am going to talk about ecosystem services of agroforestry. As for soils, regulating services include hydrological cycle, waste disposal, climate, carbon. As you see here on the slide, supporting services are provide support for plants, provide nutrients and soil formation, provisioning supply of food, water, fiber, fuels, and these categories. Okay. Soils are under severe threat. According to FAO 2015 Status of the World Soil Situation, have identified 13 factors affecting soil degradation. First two factors are mainly affecting erosion, right? Losing soils due to water and wind, and losing soils, losing nutrients, organic matter, and compaction, waterlogging, and all the reasons. So the causes of soil degradation is different from region to region. As you see here, worldwide, about 35% of the soils are impacted by overgrazing. Agriculture impacting about 28, 30% of impacted by forestry. So soils are under a severe threat. So the simplest example is splash erosion. A large raindrop falling on the ground has 2 megajoules of energy. So that can detach soil particles and disperse soils. So that is causing the erosion even on flat soils. With increasing rainfall, soil erosion is caused by rain. Decreasing rainfall and wind, soil erosion is caused by wind erosion. So we have a small range within that region to maintain our soils for land productivity and ecosystem services. So this is to give an idea about world soil situation. In Europe, these red areas represent high risk, according to several studies. A recent study has estimated actual soil loss is 3 to 40 times higher than the estimated values. In the US, each red dot is 6,000 acres, and we have 54 million acres with highly erodible soils. And yellow dot is 6,000 acres. We have 154 million acres with non-highly erodible soils. So these values are about 12 times lower than this estimation. So what happens when the soil is lost? It loses land productivity. This is a study in Iowa. In loess material soils, corn yield is decreased by 13%. Glacial soils, corn yield is decreased by 30%. So where does it get accumulated? In lakes and finally end up in the ocean. If you look at these two pictures, it shows in 1901 there were less than 10 hypoxia zones in the world. Now we have 400 hypoxia zones. During the last 100 years, hypoxia zones have increased by 400% in the world. So first factor I am going to talk about is carbon sequestration by agroforestry practices, because carbon is the main ingredient that stores water in the soil, provide nutrients, improves soil physical, chemical, biological properties. If you compare the root distribution patterns, corn, soybean, grasses, and trees, as you see here, just not the above ground part, below ground part, it takes time, but 50% or 40 to 50% is carbon in this area. Just to give you some ideas about numbers, if you have poplar, it can sequester about 20 megagrams of carbon per hectare in the above ground and close to 5 in the below ground. Look at corn, soybean. Below ground and above ground total is less than 5. If you integrate agroforestry, just 20% of the land with alley cropping like poplar, this number can increase from 5 to 7 to 8. 2 additional megagrams of carbon per hectare of soil if you have 20% trees in your farm. These numbers are not too far from world scale. We did a study looking at carbon sequestration potential in the US. We considered 154 million hectares of cropland, integrating 10% LA cropping, 5.6 million kilometers of rivers, 5% of rivers with riparian buffers on both sides, 30-meter wide. We came up with the number 640 teragrams of carbon per year in the US. So these numbers are not too far from the numbers came up by others. He has estimated managed forest, cropland, and total is about 700. So if you can implement the agroforestry, windbreaks, LA cropping, riparian buffers, we can increase the carbon sequestration potential in US agricultural land, grazing land, and riparian areas. So Dr. Honeycutt explained this graph in the morning in much more details, which shows if we can increase the carbon from organic matter from 1 to 4.5% in the soil, it can increase available water content by double. Here it's about 12, this area is about 24. Just increasing the organic matter from 1 to 4.5 doubles the available amount of water in the soil. USDA has developed this figure. If 1% additional carbon in the soil can store 150 days of flow in Niagara Falls, just 1% carbon in the soil in the US agricultural lands. This is a study recently published in Nature. They used 250-meter resolution MODIS satellite data and estimated total agricultural land in the world is about 22.2 million square kilometers. Out of that, 43% of the agricultural lands have more than 10% tree cover, either LA cropping, individual trees, or near the riparian buffers. More than 43% of the ag land has more than 10% tree cover. And because of the trees, carbon contribution of carbon by trees were greater than 75%. During the last 10 years, 2000 to 2010, tree cover in ag land has increased by 3.7%. That shows the potential of agroforestry for improving soil carbon throughout the world. Now we know carbon can be increased by agroforestry. But I want to show how agroforestry can conserve or retain soil and nutrients in the field. These two studies were conducted in Missouri. This is a row crop study, northeast Missouri near at the Greenlee Center. This is at Hawk, about 40 miles west of Columbia. At both sites we have flumes, approach sections, flow meters, water samplers. We measured water content changes within the grazing management and row crop systems. Just to give an idea, we planted the trees in these buffers in 1997, and now these trees are about 6 meters tall on average. Pin oak, bur oak, and swamp white oak planted alternately, 3 meter spacing in these buffers. We monitored water coming out of the edge of the watershed. Here water samplers, this is grass buffer, agroforestry buffer, and the control watershed. Because of the damage, initially digging holes, planting trees, both watersheds with agroforestry and grass buffers lost much more runoff, that means much more sediment and nutrients. With time, but those two management practices help to reduce losses of sediment and runoff. This is the results of this study published in JEQ 2011. Sediment reduction, when it's retaining sediment compared to the control, is about 39%, nitrogen 43%, phosphorus about 48%. This is just the results from the surface runoff. And these management practices also help retention of nutrients in the groundwater. We did this study at Hawk. This is the agroforestry buffer, poplar trees. We have deep wells, summit, mid-slope, and down the buffer, summit, mid-slope, and down the grass buffer. This is how it looks in a schematic diagram. Summit wells are about 12 meters deep, middle wells are about 11 meters, and the wells down the buffer are about 4 meters deep. We continuously collected water samples every week from 2014 December to 2016 December. So always summit wells had much higher concentrations of nitrate, that means these wells, and total nitrogen. But wells down the buffer had very low concentrations of nitrate and total nitrogen. Some statistics. So summit wells much higher, as you see, mid slope. This is the interesting point. Down the agroforestry buffer, down the grass buffer, as you see here, 3 times lower concentrations of total nitrogen and nitrate in the deep wells down the agroforestry buffer. Because now these trees are about 18-20 meters tall, you can assume that root systems are also much deeper. In addition to denitrification, soil storage, these trees are also helping to reduce nitrate in the deep wells compared to the grass buffers. So far I have shown results of agroforestry retaining soil and nutrients as we have observed, but we don't know what is the future of these kind of management practices. So if you can do a modeling work, because we have topography, soil management data, we looked at 6 different scenarios, 10% here, 10% here, V shape, all the buffers here just like a riparian system, different shapes. We did calibration and validation. Those results were very good, as you see here. Performance statistics are much acceptable. What you see here is when you have a buffer system, this is at the Greenlee Center, this part is flat soil, 3 to 6% slope, 6 to 9% slope. When you put buffers at the edge of the watershed, that is near the stream, and in the middle, that has the most effective control, reduction of losses of runoff, sediment, and total phosphorus. This is a 30-year simulation study. So to see what will happen if we continue these management practices for another 30 years. You may have seen these figures. Riparian buffers improve bank stability, reduce sediment, soluble nutrients, but different buffer widths are required. 2 studies have looked at, these are 2 review studies. They use so much, about 17 to 120 papers to understand what is the effect of buffer width on reduction of sediment and nutrients. As you see here, wider the better. We looked at the water storage capacity, how these buffers can help improve water storage in soils. We put different types of soil moisture sensors at 5, 10, 20, 40 centimeter depths in the crop area with 4 applications around the trees to look at how these systems help store soil moisture. In October, after the end of the growing season, beginning of the hydrologic cycle, rain causes soil moisture to go up, because this is October 6th rain. Soil moisture went up in both agroforestry and corn areas. Then the October 11th rain, soil moisture went up much higher in the agroforestry areas, and next rain also, which shows because of the improvements in soil physical, biological, chemical properties, this system can store more water. This is at 5 centimeter, 10 centimeter, 20 and 40 centimeter depths. All 4 depths show agroforestry areas were able to retain more water compared to the cropping areas. And soil compaction is another issue that is identified as a degradation factor caused by machinery and animal. Soils can be evaluated with X-ray technology, CT technology, microcomputer tomography. We did soil water infiltration study on those both sites. With the row crop site, as you see here, agroforestry has much greater infiltration. Grazing study, these are the rotational grazing and continuous grazing. They had much lower hydraulic conductivity compared to the agroforestry and undisturbed grass buffer, which shows they are much stronger in terms of soil physical and biological properties. And we looked at soils using an X-ray machine, took our samples at 5, 15, 20, 30, 40 leps, and took it to the X-ray machine and looked at. This is the rotational grazing and continuous grazing areas. Black dots represent soil pores. This is the agroforestry buffer. This is the grass buffer. As you remember, these trees are now about 18 to 20 meters tall, and they have deeper root systems, much more porosity compared to rotational grazing or continuous grazing. And there is a demonstration by USDA that shows the stability of water stable aggregates. Agroforestry has much more continuous plant perennial systems at much more stronger stable aggregates compared to cropping systems. And we also looked at biological parameters. This figure shows enzyme activity, dehydrogenase, beta-glucosidase, glucosaminidase, and FDA. Always crop site had much lower enzyme activity compared to the perennial systems of grass buffer, agroforestry, or grass waterways. Antibiotics is a serious issue these days. This is the antibiotic used for human health, about 7.7 million pounds. For animal production, poultry and meat, we use about 4 times more antibiotics, close to 30 million pounds a year. So only 20 to 30% of the antibiotics retain in the animal body. The rest is either getting to the water or soil. This study used 3 different soils, Armstrong, Huntington, Menfro, and looked at the antibiotic bonding capability of different soils. The gray areas represent stronger bonding of antibiotic compared to crop and grass buffers in Armstrong soils, these 2 antibiotics. So that shows when you have an agroforestry or grass buffer system, they can strongly bind antibiotic to the soils and stop those antibiotics getting into the deep water or stream water. Usually agroforestry buffers have multiple tree species, right? The lowest line shows antibiotic degradation capacity of poplar. If there is a rain 6 days after the antibiotics are given, only 15% of the antibiotics will be lost into the stream when you have a poplar system. So it shows multiple tree species, grass species, shrubs in agroforestry buffer is more effective in terms of retaining antibiotics, degrading antibiotic before it gets into the water. This study was done at Bradford Farm. Chung Ho Lin, Dr. Lurch, Dr. Goin, and Dr. Garrett were the PIs of the study. This is a rainfall simulator. Plots are about 16 meters long, 8 meters of the feeding area, and there's a buffer. Different buffers were compared, tall fescue, native grass, and mixtures. This is the control for these 2 antibiotics. Even the control had some degradation going through the buffers. As you see here, tall fescue, hedge, native grasses were much more effective in terms of degrading antibiotics. Within the buffer, about 4 meters, antibiotic concentration has dropped to 20% from original 100%. And they did another study looking at herbicide, 3 different herbicides, similar results, degradation as it goes through the buffer system. And agroforestry buffer systems can help buffer soils of extreme temperature conditions. That's helpful to store soil carbon in the soil for a longer period and also to different microbes. Agroforestry buffers and perennial prairies, grass buffers have very low thermal conductivity and diffusivity and higher volumetric heat capacity. That has more buffering capacity from the extreme temperature conditions. So, and these systems also have higher carbon and lower bulk density. Then another factor is within the agroforestry systems we have multiple trees, unlike a monocrop, trees, grasses, shrubs. So the diversity is higher in these systems compared to the monocrop systems. There are several studies. I selected this study done by Wall. They compared monocrop and agroforestry for mean density of ants, termites, millipedes, centipede, beetles, and earthworms. As you see here, all these counts are higher within the agroforestry system as compared to the monocrop systems. I want to explain 3 different studies at in different countries, US, Canada, and Russia. You might have heard about the 1930s dust storm, and 2.5 million people left this area to California. And 1934, President Roosevelt initiated a program called Prairie Forest Program. So that was undertaken by Forest Service. They planted windbreaks between Canada and Texas, about 1,150 miles. It's about 100 miles wide. 217 million trees were planted in this area. This is again to show when these trees are planted, it increases carbon in the soil. Recent study has shown these trees have sequestered 1 to 4 megagrams of carbon per hectare under pines, and 1 to 14 megagrams of carbon per hectare with the deciduous and broadleaf species. So you can see the change in soil properties because of the windbreaks. Another example is in Canada. Wind erosion is very common, lower productivity, and they started a project called Prairie Farm Rehabilitation Act, which was passed in 1935. Even before the act, between 1892 and 1930, farmers have started planting windbreak trees by hand. Government has established several nurseries. Planting material were distributed. This is at railway stations. There is a tree planting campaign car, so that to promote and give suggestions and advice to people how to plant, how to maintain these buffers. Demand for seeds and seed demand and seed supply. During this project, they have planted 610 million trees. In 1980, during a drought year, during that year they have planted over 11 million trees. However, this program was ended in 2012 because of the budget situation. After 1981, 610 million trees were planted. Canada Ag Department has estimated it has stored 218 megatons of carbon in this windbreaks and shelter belts. Other service and good benefits are over $600 million. Another example is in Russia, a 1946 drought and subsequent famine. 500,000 to 1 million people died because of poor land management, also lower crop yields, lower manure application. So Joseph Stalin proposed great plan for the transformation of nature. So the management or the activities are based on Dokuchev's research activity. You must have heard about this. He's a soil scientist in Russia from 1860s to 1920 or so. I cannot remember the exact date. He started windbreaks and shelter belts in his farm. So that's the foundation for the establishment of windbreaks and shelter belts in Russia. So they have planted 5.7 million hectares of windbreaks over a 15-year period and 0.12 million hectares along major rivers. So you could imagine the amount of carbon sequestered by these soils because of the windbreaks. And not just carbon, improvement in soil, physical, chemical, biological properties, water storage, reduction of nutrient sediment losses from sites, and also increasing crop yields. There are so many studies that supports when you have a windbreak, crop yields are going to be higher. I have selected these two studies. So it's not in the wet area. This is a picture from Africa. As you see here under the trees, corn plants are much darker green, much taller and healthier because of the stressed soil conditions. You must have heard about hydraulic lift. Tree roots can bring water from deeper soils and put it back in the surface soil. So these trees must be doing that. So bringing water from deeper soils, bringing it here, reducing the stress from the heat, and providing better soil conditions. So integration of trees can always help improve soil ecosystem services. But however, agroforestry practices need better management and understanding, because when you integrate trees, they are competing for nutrients and resources with the companion crop. So you have to have a better understanding of better management practices, either root pruning, thinning trees, removing branches, in order to maintain crop productivity. Thank you very much for listening to my talk. Do you have any questions?
I think we have time for perhaps one or two questions. Thank you, Ranjith, for that presentation. If there's maybe one or two questions we can take from the audience before the panel discussion. Yes.
Well, not just this person, but several others I've heard mention the use of poplar trees. Is there anything particular about them, or simply that they're fast growing?
They are fast growing, so that means they are taking. Poplar trees are good for moisture available condition. If you are planting a poplar tree in dry area, it will be removing a lot of water, and it's not going to be good for the companion crop.
Would you not want to intersperse some of that, though, with hardwood plantings that would last longer, because the poplar tree is
Hardwood
very
planting is
susceptible
good
to
because at our Greenlee
wind.
site we have hardwood trees. At Hawk site we have poplar trees,
So the
depending on the situation and objectives of the landowner.
Time for one more.
So you'd mentioned the biodiversity that's created by the shelter belts or by the agroforestry practices. I was curious, how far out into the fields does that extend?
Which property? Soil moisture retention or
No, you'd mentioned the earthworms and centipedes, and those levels were a lot higher in that area.
in the multiple tree species area compared to monocrop area.
Yeah, but I was thinking, if you had a shelter belt next to a crop field, does that benefit extend into the crop field, or is it located
Not
only
too
in
far into the crop field because that's a monocrop, right?
Except this was on, just to react to that comment, what you find is that the tree rows enable insects to migrate deeper into the field because they can live in the understory environment underneath the tree rows, so that basically you're allowing insects to go from woodlots and penetrate very deeply into fields because there's habitat that they can overwinter and move out into the fields from the tree rows.